How did Meta react to this? You see ChatGPT getting released. How do you move on and start building Llama 2?
I love this sentence about it's not AI anymore when it works. The human type a prompt, if the model generates 10 different examples, even if like 9 of them are very bad, it's enough that one is good so that the model learns and improve. Very often you want to retrain your model so that the next week, when the annotator will ask the model, you have now a new model that learned that and will generate 9 good examples for this one. And among the 9, probably that one will be even better than the one you had the last week.
Do you think we'll reach AGI?
Oh, yes, I'm highly confident.
When? This is probably the most complete LLM course I've seen so far, from beginner to advanced developer by Towards AI. It's basically a one-stop conversion for anyone who wants to become an LLM developer, and the course has over 90 lessons to go from beginner to advanced in the field. It's both very practical and industry focused, but also quite technical, and you will cover a lot of technical topics like RAG, fine-tuning, agents, audio, and caching. So if you're interested, check out the link in the description, and don't forget to use the code AIStories10 to get a 10% discount. All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact, and I will be your host. So today, our guest is Thomas Scialom. Thomas got a PhD from Sorbonne University in computer science, where he worked on natural language generation with reinforcement learning. And during his PhD, Thomas managed to publish around 20 academic papers, and we'll dive into this achievement in the podcast. After that, he joined Meta, where he's now a senior staff research scientist and built some of the world's most famous LLMs like Llama 2, Llama 3, Galactica, Code Llama, and he's now currently working on AI agents. So this episode will be all about generative AI. If you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right. Hi, Thomas. Very happy to have you on the show. First thing I want to ask is, how did everything start? How did you get into this world of AI and machine learning?
Hello, everyone, and thanks for having me. How did it start? Look, I was actually working in finance, and I heard about AI. I think at the time of AlphaGo, basically. I wanted to know more about this magical technology, which was deep learning, and beyond the success of those models on AlphaGo and the others at the time. It was much before large language models and NLP. Turns out after 6 months at a degree at École Polytechnique, it was an executive degree, like the 2 days per week, at the end of which I discovered what is machine learning, the basic principles. I coupled that with Andrew Ng, a famous MOOC. At the end of which I was like, okay, this is machine learning, that's cool, but I have no clue what is deep learning. And I decided to drop finance and start a PhD in the field.
And how did you get into NLP then? Why NLP?
I mean, turned out I had an offer from a company to do like this PhD within academia and then startup to get still a foot in industry. The company was about natural language processing, not generation, but my PhD was about generation. To me, it wasn't. So there was two interesting things here. One is from a finance perspective, predicting the next token or predicting the next stock move isn't that different philosophically. It's all about predicting the future or predicting something or intelligence, basically. The other thing is that you have probably a much better field to work with the language because it's more stationary and it's much more about true intelligence, which is what makes human like unique compared to finance. So thinking about that, I didn't think at all about that before getting an offer there. But thinking about this, I was more and more convinced actually it's more an opportunity than something else. At the beginning, I was like considering just finance. And then the more I learn about it, the more I read papers, the more I became like certain to I should do a PhD in this field.
And so what was like natural language generation before ChatGPT? When did you start working on it, and what kind of algorithms were you using at the time? Yeah, what was your PhD about?
So uh, I start I started basically at the year of just before
Okay.
BERT, the first one of the first language model. BERT was not a language generation model, just a
Hmm.
classifier. So it was all the time we adopted those methods to generation. I started when attention is all you need. Transformer paper was already there. So actually, that was my first project. Uh, I was working on summarization. So you get an input and a newspaper, an article, and your model has to write a summary. Um, I remember some slides. It was seconds to seconds models where basically my output was a garbage, like three different words that were like nonsense. And as soon as you had like one fluent sentence, it was like already a success. Not talking even about hallucination. Um, I quickly oriented the project toward reinforcement learning. There was actually a notable paper from Romain Paulus, Richard Sutcher at Salesforce about summarization and reinforcement learning, where basically they were reinforcing the algorithm a bit like AlphaGo, but on a metric. Metric was named Rouge, which is a metric to measure similarity between a ground truth summary and the generated summary. And so starting from there, you discover that, okay, you improve Rouge, but actually you decrease the quality of the text. And that is because the metric is not perfect, it's actually very bad. The correlation was like something like 10% with
Hmm.
human. Um, and so then the problem becomes not only to work on the algorithm themselves, but also a better metric.
So it's kind of the pre-reinforcement learning from human feedback, right?
Exactly. And I had a ton of papers inspired where I was always citing actually RLHF early papers from OpenAI.
Okay, okay, very cool. And so, yeah, what kind of I mentioned in the intro you managed to publish 20 papers, around 20 papers on this topic. Um, for those who aren't in a PhD, that's like an amazing achievement. I know how difficult it is to get like even one paper at the top conference, but 20 is like amazing. So what's the process? What kind of process do you go through to publish a paper and yeah, successfully publish a paper? How did you manage to achieve this?
I think there's different reasons, to be honest. One is I was lucky to be in a field with so many opportunities. Like, think about my first conference before publishing my first paper was when BERT was announced. I was starting my first project on re-implementing a transformer on summarization. Like, the years that followed that were plenty of opportunities. So that's one, and it's luck. Second thing is I had an amazing advisor, Jacopo Stanau, who I remember the first paper. I was like literally unable to write two words in English that makes sense like following a scientific template. I had no experience there, and he helped me a lot to structure how to organize ideas, protocol, experimental protocol, writing it. And without this mentorship, I will not be able to get there. And I guess I had also like probably some taste for research directions, ideas that I wanted to implement, and hard work, coupled with hard work to implement them, execute. And so probably the sum of all that enables to get some cool ideas at a time where everyone is excited about it, get some early results, and be able to publish.
So you were at the right time, had a good supervisor,
Yeah.
but also some hard work. But yeah, what's the process that you go through? You have an idea, you test it, and then you publish a paper. You try to how do you try to test this idea? Do you try to test it quickly so that you can move on to another idea if it doesn't work? Yeah, keen to get a bit deeper into the process.
Yeah. Actually, in general, I get ideas by playing with the model or by reading papers that are state of the art. Basically, playing with the state of the art approach, whether it's a paper or an implementation, the code of the implementation, playing with the model. And it kind of appear very clear always to me what is like the bottleneck, the next things to solve. Like basically coming with what is the best solution as of today and what are its limitations. How to make it better. Well, is it like a problem of hallucination? That was a lot of the case at the time. Is it because the architecture itself, the information doesn't flow well? There's a bottleneck, so maybe you can solve this problem and it will obviously improve the final results. Um, can be like, think about that just as an example, like context len. Um, if you have like an algorithm that can process only 512 tokens as an input, and your corpus is in average maybe two or four times more. Of course, you cannot get all the information. So how do you deal with that? Then you can think about different methods. There's longer context attention, but you could also think about hierarchical attention or like doing summary of summaries. Hierarchical way. There's plenty of then ideas you could explore to solve this problem. And one interesting thing in deep learning is um, a lot of those ideas often work. Then there's the question of which one scales the most, is the most simple, and in general, that's the one that win. But as long as you have an architecture that process properly the information and you can learn, it becomes easy to learn to. And there's not a single solution to a problem. So in general, yeah, the problem was to identify limitation, think about the solution, and implement like basically one or two ideas around the solution.
Okay, makes sense. So play around with state of the art and see what they still cannot do or what they struggle with, and then try to find solution to those issues. Seems
Yeah,
easier said than done, but sounds like a great approach.
yeah. I mean, it's interesting because so I had also like some discussion with folks asking like, yeah, but what would you do differently, etc. Actually, then the next thing which I actually learned at Meta and not at during my PhD is probably publish less but on more impactful things. And you can think about a ton of limitations, but then the next thing is which limitation will actually be critical for the next improvement versus which one is actually like will become obsolete in 3 months, 6 months, and it's superficial as a problem. Like maybe scale will just solve it and like the things. So I think finding limitations and finding solution, writing a paper is kind of easy, uh, more or less. Now what's become harder is okay, but which one is actually worth the time to actually work and spend a lot of time to solve? Which I think the field overall, not just me, have moved forward with less papers, more impactful in general.
What's the paper that you're the proudest of then?
Interesting. Maybe either Toolformer or Llama 2. Llama 2 because, I mean, that was a massive impact worldwide. It was the first open source chat model. We learned a lot of science during the paper. We kind of reinvented RLHF at scale, which I was very junior at the time at Meta, and just a project at this scale with this impact, discovering the science behind that and understanding more the principle of this science and methods were really cool. And it paves the way toward now Llama 3 and what's next. Um, and Toolformer, because I mean, you mentioned I'm now working back again to agents. Toolformer was kind of the first agent of its kind with an LLM calling tools. And that's a very long-term direction I have spent a lot of time to think and to work on. In fact, it's interesting because the transition between the two, it's I worked on Toolformer, and at the end of which my conclusion, and maybe we'll come back to that later in the podcast, but it was before Llama 2. It was just we published it few weeks after ChatGPT. Meta didn't have at the time any instruction models, chat models, and my conclusion was to move to this direction and to push forward, we need first to build internally foundational models like ChatGPT and GPT 3.5 at the time, to then empower agents with like intelligence from the LLM. And so we needed Llama 2, Llama 3 to move back to agents basically.
So you finish your PhD, you join Meta, and you first work on Toolformer. That's one of the first thing that you work on, and then you move to working on Llama 2. Is that right?
Okay, almost. I joined to a team called Papers with Code.
Okay.
The website is quite famous. It was a company acquired by Meta, um, which was attached to FAIR,
Hmm.
Fundamental AI Research. Meta. And the project I joined was how can we scale basically this website that organizes a bit science of papers and the code attached, the scores, the benchmark automatically. How can we scale it to the next level for science in general? And the solution was a language model that can read all the science in the world. That was
Okay.
Galactica. So I joined to this project. Um, I quickly moved to instruction tuning Galactica. It never came out. We didn't never open source it, but it was actually the first blocks for Llama 2. Um, and I did Toolformer in parallel as probably my vision was after maybe Galactica Instruct, if things were moving well, we should scale Galactica Instruct and integrate the tools like in a spirit of Toolformer.
Okay, so can you explain a bit Toolformer then, because you're proud of this? For those who aren't familiar, what is Toolformer? It's pre or within the same time as ChatGPT, so it's still early stage of agents. But yeah, what did you do there?
So let's contextualize. It was published what 2 years ago in February, like 3 months before, 3 months after
Okay.
ChatGPT, basically. Um, you can think about this time as actually the sequence is we published in mid-November Galactica. It had this massive blast. Everyone was already excited about LLMs, but it was quite controversial, in particular for science. We actually removed the demo after 2 days. And there was like a lot of people supporting it on Twitter. This is the future. This will be super helpful for science. A lot of people actually saying this will destroy science. So it was kind of an experience. Um, then 2 weeks later, ChatGPT is released with the massive impact we all know. Um, and for the first time, this technology that we were working on went into the hands of the public, general public. Um, ChatGPT, like a lot of folks in science were like in the researchers in AI were actually surprised by how good this model was. They didn't realize before that this technology was already there. Um, and I remember when we published Toolformer, it was not based on ChatGPT, but basically you could think about it as ChatGPT combined. It was a language model that was open source at the time, combined with tools. The idea was that ChatGPT and all those language models are close. So if you ask a question, it's not grounded. It cannot execute code. It cannot query the web. It cannot use a calculator. And that's stupid. um, and so to give to the next level of abilities and scalability, imagine if these models had access to these tools. Then it can become really, really good at math, really, really good at calculus, really, really good at getting grounded information and maybe solve factuality. Um, And so Toolformer, we had this self-supervised method to basically teach the model when to call a tool and when not, to improve its accuracy, its next token prediction, basically. And we shown in the paper that you can actually do better in a lot of benchmarks with a model 100 times smaller if you give it the ability to use those tools. And so it was perceived by a lot of people as everyone see where it was going next as like, yeah, give the strength of these large language models, which ChatGPT was state of the art at the time, coupled with tool use, and you can have something that really will change the world.
Okay, so the beginning of AI agents, which is getting very popular now. We'll definitely get back to this topic at the end of the episode, but I'm interested in what you said about ChatGPT going out and the world realizing, yeah, how powerful this technology was. First thing I was keen to understand more is, were you surprised by ChatGPT, or did you already know by working on Galactica and other models that the technology was there? And did you realize that it was so close to? well, so powerful?
It's interesting. I think it was a bit of both. I knew the technology was there, and from first principle, if you like, you can get an expectation that it will become better and better and scale. And at the same time, I was blasted away by like how good it is. Like playing with it and feeling how good it was surprising. It's hard to internalize how good this is from a curve if you don't play with this technology.
Okay, okay. So you were still kind of impressed. It was still better
Yeah,
than what you expected.
yeah,
And how did you? I mean, how did Meta react to this? Then you see ChatGPT getting released. How do you move on and start building Llama 2?
right. Let me tell you, but also I'm remembering now, and actually, all this technology was blasting me away. Like even Galactica that we had internally, and playing with that and doing some stuff, playing with it, fine tuning a bit, and seeing. I was surprised, and every time there was some magical things with those models that were happening, and it was surprising. It was not just ChatGPT, but all this technology. Uh, so it was a mixed feeling between I know that every time I'm surprised, but I'm still surprised. And actually, I love this sentence, but I think it's maybe it's Nick Bostrom, I'm not sure, but like you can measure the impact of a technology to the amount of science fiction it vanished. And I think actually the world has changed. With Nick Bostrom also said that uh, it's not AI anymore when it works. You know, we have this long history of chess is super hard, and then you have Deep Blue. Chess wasn't that hard. You can solve it that way, and so on and so on. And that's the same that all along the history. François Chollet talks a lot about it in its art paper very well. I feel that ChatGPT was a moment where it works, it's AI, and it's still science fiction for a lot of people. So it's a pivotal moment in AI in that regard.
Yeah, I think a good also a good thing about, because I was also in the field before ChatGPT got released. I worked a bit on NLP, and so you could feel that we're getting there. But yeah, I agree with you. I didn't expect it to be so good. The other thing is also that it was so easy to use. It's not just for developers anymore. It's
Yeah,
everyone in the world could go and ask a question and get an answer. And maybe that's why also it's kind of took everyone by surprise and got so much attention.
yeah, well, exactly.
So what do you do then at Meta when you see ChatGPT getting released, and how do you start building your own LLM then? How challenging was it?
So actually, I was actually working literally on this technology before it was released, and we had an instructed version of Galactica. The plan was to release it in Overleaf, you know, the Google Doc for researchers to type papers. We had a partnership with them. Um, we decided to delay it because of Galactica weird reaction, public reaction. But it was there. I had built the first pipeline algorithms for not RLHF, but just instruction tuning on super fine tuning, created a lot of synthetic data. So then you had ChatGPT. You probably had all the December month where it was very weird. What will happen? We are nowhere, and so on. Things. And Zook, I think early January, decided to, hey, I want this technology and I want to lead there. And then naturally, like we were quite advanced in the Paris office in particular, because I was working on this technology and instruction tuning. We had Galactica as well in Europe with London and Paris team. We had our colleagues working on Llama 1, which was released a few months later in February, and with the success, you know. And so we started actually working on combining Llama 1 and me and Galactica team on Llama 1 plus instruction tuning and RLHF. And I basically started to build intuition of super fine tuning, RLHF, scaling it. The big unknowns were okay, I worked a bit on that with a small scale. It kinda works, but to what scale and what algorithms you need to have to make it really work with like millions of dollars of annotation uh, and to compete. And honestly, I was like some mornings, but to get to ChatGPT, do you need 100,000 with a different algorithm that I have examples? Do you need 100 millions of examples that they had from their API? You just think about it, you try to guess, but you literally don't know. So that was all that. We started working on that with commitment up to Mark Zuckerberg on this technology, and we executed fast. We were lucky to get to good intuitions and release Llama 2 a few months later.
So what was the answer then on the data? How much data do you need to make it work? How many annotations?
It's, I mean, it's specified, I think, in Llama 1 paper, but the other magnitude, Llama 2 paper, it was 1 million annotation for LHF. But I think the main novelty that I understood is there was this debate still at the time at Meta at super fine tuning versus RLHF. Is RLHF really something or actually just asking humans to write? Maybe it's less scalable because it takes more time, but it's maybe better. No, in fact, machines were already writing text better than humans most of the time. And so RLHF was just the most scalable way to get the best quality data, not just a lower price, but also quality to leveraging the discriminative capacity of a human that is better than its generating capacity. In other words, if I show you two poems, you can tell me which one you prefer. But if I ask you to create one, it's going to be more challenging, at
Mhm.
least for me.
And so, okay, maybe just to put things into context, so there are three, for the listeners, there are three big steps to train an LLM, or they were at the time. So one is like model training by predicting the next token, which is the core model, like Llama 1 that you mentioned. Um, the second one is instruction fine tuning, so training the LLM to reply to a question, for example, by giving an answer. So you give it a question answer, for example, and you train the LLM to provide answers to the question you ask. And then the third one is reinforcement learning for human feedback, RLHF, where you train the LLM you align the LLM with human preferences in some sense. Do I summarize things correctly?
Mostly, I guess the question is between the second and the third stage you mentioned.
Hmm.
So you need obviously the second one to start to align the model
Hmm.
such that it follows instruction instead of just generating the next word. The example I can give you is if I give you as a prompt a question without the question mark, if you are still in the first mode and you haven't started the alignment, the model learns to complete the
Yeah.
sentence, so it will generate the
Hmm.
question mark. Now, with a bit of example, it learns to align and to answer your question, follow instructions. But the question then you have actually two competitive methods. You could still actually ask humans to write text. This is some will argue, and in particular at the time it was the case even more, that the machine will generate degenerated text and that a human is actually
Okay.
asking an author to write or a text is what the human will prefer. And you could think about that was my case. At the beginning of the project, I was, hey, if I have this amount of money, I'll spend 90% on text written by human and I'll explore a bit the other method. And very quickly, we realized with some human evaluation, analysis, looking at the data, that the model was already generating better text than the high quality annotators we had for the project.
Okay. And so the key was to use RLHF based on human preferences by showing humans a few candidate answers and
Exactly.
telling, well, and yeah, and trying teaching
Yeah.
the model to generate the best answers, the answers that humans like the most.
Yeah, exactly. And you can think it's very intuitive. Like the human type a prompt, if the model generate 10 times, 10 different examples, it, even if like 9 of them are very bad, it's enough that one is good s- so that the model learns and improve. And the next, and one of the key things we implemented that I think changed completely the picture and was key of the success is that as very often you want to retrain your model so that the next week, okay, now you have learned from this example, 9 were bad, one was correct. You want to learn to teach this example to the model very quickly, so that the next week, when the annotator will ask the model, you have now a new model that learned
Hmm.
that and will generate 9 good examples for this one. And among the 9, probably that one will be even better than the one you had the last week.
Okay, yeah, makes sense. And so according to you, that's like the big
Yeah,
improvement that made Llama 2 better, much better than Llama 1, or I mean, it's not, they aren't comparable because Llama
yeah.
1 wasn't instruct tuned and didn't have a RLHF, but do you think that's the big improvement to arrive to a ChatGPT like model?
Oh, definitely, yeah.
Okay. And that's something that wasn't known at the time, that human human had to choose. It was better to make human choose between different options.
So that's the thing. There was some papers, hopefully for us, we didn't have to
Hmm.
reinvent all that science from scratch, from OpenAI, Anthropic that led the field before. But no papers on explicit ChatGPT. You don't know what actually they did at scale. You don't know
Hmm.
how they combined simple method they published before to or more sophisticated things and where the performance come from. So we had some guesses, but a lot of unknowns. A lot of people at Meta didn't think that LHF was a
Hmm.
thing at the time, and we learned that it was a thing just by exploring, trying it.
Okay, yeah, no, very interesting to see how, yeah, because now it's kind of the, I mean, there are other techniques now with DPO, but it's yeah, interesting to see.
It's still LHF DPO.
Yeah, yeah,
It's basically you DPO. You have two outputs from the model. You ask a human to choose which one if he prefers, and you train the model on the preferred one, and
mhm.
a negative loss on the other one. So it's LHF in some sense.
The last question I have on Llama 2 is, what about open source? Like, was it a debate, and why do you decide to open source it compared to ChatGPT, which is closed source?
I think it's a lot of different reasons. Um, First of all, when Mark Zuckerberg called Jan LeCun 10 years ago to found Fair, the condition from Jan was he already mentioned that um, let's make it an open source first lab, and it has been in the culture of Facebook, Meta, and Fair in a long time. So that was natural and very aligned with the researchers. At the same time, Mark Zuckerberg had this vision of making Llama the Linux uh, open source of AI, which we are working harder to still make it happen and make the model better and more adopted. So it was an alignment of a lot of different perspectives at the company, which makes the decision quite easy. The last thing probably is it was probably not a lot of people remember, but at the time, in terms of what does it what does it mean for the world to have such model open source, it was a big deal in terms of safety, security, things like that. The people were really scared. So we couple that with a huge effort on safety to make sure that the model will be very safe. It was actually one of the critiques from the public. It's too safe, but at least it meant that we did our job great.
And how do you make the model safer? Is that with RLHF again?
Absolutely, yeah. But with a different protocol, basically, you ask your annotators to judge a sentence that will say, no, I don't want to answer you this question, as better than the other one.
Okay, okay, makes sense. So very cool. You build Llama 2, it gets released, gets quite popular. After a couple of months slash years, you move on, you build Llama 3.1, 3.2, 3.3. Um, what was your role there in Llama 3, building Llama 3? And what are the different models available? Because there is 3.1, 3.2, 3.3, different models within those versions. So yeah, what was your role there, and what are the different Llama 3 models? How do you see them?
I I was mainly leading the post training for until Llama 3 preview, scaling the team. Then I progressively, after scaled, stepped down, just fix some fires around until the end of Llama 3
Hmm.
into one last summer to transition to agents and set a team there. Um, Llama 3.2, 3.3, you can think about them. I think 3.2 is a multimodal version,
Hmm.
3.3, and every next version is just a better one than the previous with small changes a bit better in post-training, some fixes, maybe more on context. Every new version will have a small improvement like that before a step change for Llama 4.
And what's the big difference between Llama 3.1 then on the post-training phase, which is the one you worked on, compared to Llama 2? Is there a big difference? How did you make it
Yeah,
even better?
I think the way you can think about it is Llama 1 was a pre-trained model. Llama 2 was the first aligned chat model. Llama 3, we scaled both pre-training and chat, instruction tuning, RLHF. So we scale it both in terms of number of annotation per capabilities, but also number of capabilities. We've now on Llama 2, we were working mainly on helpfulness, following basic instruction that everyone will ask. On Llama 3, we extended that to code, um, to reasoning, math, factuality, and covering a lot more domains.
So the technical approach didn't change too much regarding the post-training phase. It's more like the data side of things that changed.
I think you can. It's fair to say so, although there were
Mhm.
some changes that we describe in the paper. But fundamentally, yes.
Yeah, we'll share a link in the paper. I haven't read those personally, so we'll share a link for those who are keen to learn more. Regarding the data, how do you do then? Do you decide on capabilities that you want the model to have and then you build data sets around it? Like how do you decide those RLHF annotations? Should be quite a big challenge.
It is a big challenge, and it's an open research question. Also, it's everything is interconnected, so it's hard to measure correlation, which are linear. Um, so it's a big deal. But in general, you have some metrics. The evaluation itself is a big
Hmm.
problem because it's hard. Everyone recognizes that. So you want to measure a broad spectrum of capabilities, but even inside capabilities, benchmarks measure different things that are, it's hard to name them. You want a big picture. You also don't want to overfit this picture. So you want to ask annotation that will cover that, but without directly cover it, so that if your method works, it will improve those benchmarks, but for good reasons, not overfitting. So they're all this game basically to measure, improve without overfitting and covering more and more dimensions better and better.
Okay, great. And so you work a lot on LLMs and then you get tired and decide to work on agents, which is the next cool thing of 2025, which is still closely related to LLMs.
Yeah, actually, I don't see them as like different in the sense agent is a next step change. Um, what is an agent? It's basically an AI system that can autonomously take actions in multi steps. In some sense, with chain of thoughts, LLMs are already close to that with some tool use, Toolformer. And my vision is just that you need basically, if you have a system with access to tools, now the question is how to execute them in the right order to do your tasks, how to navigate, how to do multi-step tasks. You need a level of intelligence to learn to use those tools to read the documentation and execute and adapt if there's a bug in a code or execution or things like that, which comes from LLMs. So to me, agent is the way I see them as of today is LLMs with chain of thoughts and reasoning capabilities that are able to that we provide a list of tools and they can solve complex tasks requiring multiple steps.
And how do you make them, how do you train them to let them know which tool they should use then?
I mean, without discussing too much what we're doing as we haven't released it, but there's a lot of open source implementations. So if I just release one, Slumberg Agent, uh, the main way is you just give the list of your functions and the description of what they do, what are the arguments, some examples, and from this example, the LLM can learn to combine them in a nested way and execute basically. Progress, observe the environment, which is a novel thing, which I really like with agents. You don't the LLM is now grounded. It's not just an LLM in that sense because it can take an action and observe the uh, change in the environment, the return basically of the functions, and so it can act on the world in that sense.
Yeah, and that's how LLM can search the web, for example. If you ask them what was the score of this football
Exactly.
game yesterday, they can answer as well. And so they're before that, LLM were trained up to a certain date, and they couldn't answer questions beyond this date. And now they can answer well up to date questions as well, which is quite amazing.
Yeah, exactly.
So, do you think agents are the future of the field? Do you think we're we're done with LLMs? Like we've done everything we could. There is some gain that we can do, but we cannot improve them so much. And the biggest gains in the field will be regarding agents, the tools they use, and things like that. Or yeah, what's the future of the field? Is it scaling LLMs? Is it agents? Is it a combination of both?
I think it's a combination of all that. I think we're not that far from AGI, and it's a combination. It will come from a combination of all those things together. Uh, Now, scaling is definitely a way, but there's different directions that you can scale. Not just the weights,
Hmm.
also the number of training for pre-training, post-training can be scaled. Now you have seen inference time methods as well. Um, Coupled with tool use and agentic behaviors, that's another way. Then you can think one very interesting direction, in my opinion. So in terms of everyone is talking synthetic data, but the fact that an agent is now an LLM that cannot just generate its own text from its own weight, but augment itself from external tools, then it can retrain itself on things that it could not produce by itself alone. And so you're not in a closed loop. So that changed everything. And all those methods coupled, I think will likely move to AGI, and some of the key directions will also become closer and closer we move there, as also optimization. How can we make it more efficient uh, at less cost, smaller models, uh, scaling laws? That
So, do you think we'll
yeah.
reach AGI?
Oh yes, I'm highly confident on that.
When?
I don't have a date, but I think we're closer and closer. I'll be very surprised if in 5 years I have a probability of 90% basically in the next 5 years.
Okay, wow, that's quite a big confidence. How do you even define AGI? Will
Yeah,
we know when we reach AGI?
yeah, it's interesting. So my definition is that uh, on the digital world, step aside like physical and robots, which will come, I'm pretty certain, but just a bit later. And it's just a question of transferring and adapting methods there. On the digital world, you can give the right tooling to an AI and it can do the task if you give the right instruction and tools. If a human can do this task, the AI will be able to do this task.
And human, like, is there a certain level? For example, a student can do one task. It's one thing to do a task.
Non-expert tasks
Okay,
in general.
so
Just Yeah, non-expert task. Take any random human, give him tools and instruction, ask him to do the task. If this is doable by a random human without expert knowledge skills, that will be doable by an AI.
but if you ask like a complex task, like writing a paper, something that only a PhD can do, for example.
I don't consider that inside AGI, but I think we will not be close. We will be very close to that once we reach this point. I just want to disentangle expert
Hmm.
skills, basically from the ability to execute well a task without expert skills. Uh, because if you set the bar to of AGI to a PhD level, then there's a large proportion of humans that won't have that. I think we're at a stage basically of then it's just building blocks. Then maybe you need to retrain the AI to add memory components, to fine tune it, to memorize and learn on the way, to personalize. But all those blocks of continual learning, memory, and those things will just be added progressively one by one, and it becomes more an integration engineering problem with some research questions than an open research question like we don't know. I think we'll be closer to we know and we just need to execute now than we don't know.
Because to me, like at the moment already, LLMs are quite good at doing tasks. It depends which task, but they are quite good. I can ask them write this little function and they can do it. Obviously, they cannot do like bigger tasks like a big website with many details, but they can do some tasks. So the point where I will be very surprised is when you ask it an open question like do this project or find a new medication, a new treatment for this disease, and it finds it. That for me would be a huge improvement and would be AGI. But for this, yeah, 5 years seems to be quite short. But I'm not as close as the topic as you. But yeah, that's what I would yeah see like super
Yeah.
AGI, for example.
No, exactly. That's more like ASI. That's what you describe. I think if you give a random human the two questions you mentioned, most of humans will fail.
Hmm.
Finding a new medication will maybe require an entire
Yeah.
organization and not just any human.
Hmm.
Like I'm pretty sure if I asked my mom to write a paper on this topic or to find a new medication, she will fail. So in that sense, I was not including that in my definition. But I think this will naturally follow quickly once you reach AGI.
Okay, so there is AGI and there is like human super intelligence,
ASI, artificial superintelligence.
which is this we might not get in 5 years, but it will follow closely after AGI.
Yeah.
So going back to agents, then everyone talks about agent now. 2025 is the year of agents. My LinkedIn is full of agent posts. Where are we today in terms of agents? What can agents do well and what do they struggle with, and what are the challenges we need to solve to make them work well?
It's interesting. I think with more and better models, they start to be good in a lot of simple tasks that produce a lot of economical value, given the right tools, the right execution protocol. um, Maybe what they struggle to, in my opinion, the first thing is being robust, which is critical for adoption of this technology. Second thing is um, task that takes a lot of steps and time. So if you ask a task that will take you like 1 hour, it's likely that those models will fail as of today. Uh, Tasks requiring 50 steps, 100 steps. We are close to that, but not there, I think. So that's the current limitation.
Okay, they can do simple things, but they cannot do things that are too complex.
Yeah, exactly.
And if we talk more about applied things, I mean, I feel like it's getting very popular in customer support, for chatbot to chat with yeah customers and replying to their questions. Do you see other applications where it works well?
Um, I mean, I'm not familiar with all the businesses,
Mhm.
and my LinkedIn is full of that. I don't read it anymore. But I think it's agent is just a big name for LLMs combined with the
Mhm.
tools. And in that regard, it works for a lot of different use cases and applications. Uh, Internally to some companies, a lot of people are doing that for not, for beyond this kind of use cases. I think what we are missing is those agents are working well with a lot of efforts and in silo for specific use cases. The next big thing in when they become robust and with longer tasks, it means a larger surface of actions, more generalization. And so it's not just like I have spent 6 months of engineering to make it work on like my use case and it's great. It's like I spend an afternoon to write my APIs and descriptions and test it, and it just works off the shelf. And it's combined with all my other agents and APIs.
Okay, so being able to play with more tools, do more steps, and also generalize, because it's true that one big challenge at the moment. I work more in industry, and building Gen AI tool for companies, and I can see that yeah, it takes time to adapt a tool to a company. It's not straightforward. It takes a lot of time because there are all those
Exactly.
edge cases. As you mentioned, it's not robust enough. There is always a few questions that it cannot answer, where it will hallucinate, it will use the tool in the wrong way. And so making them robust and generalizable is a big challenge.
Yeah, definitely. I think we'll solve that probably this year.
Okay, wow, you're very optimistic about the technology then.
I mean, see the pace of
Hmm.
progress. It's interesting. Think about we discussed what we discussed today. ChatGPT was released 2 years ago only. Llama 2 was released 1 year and a half ago. Like, if we
Yeah.
think from that perspective, what happened in the meantime is just crazy. And so I don't see any slowness, quite the opposite. We are accelerating even more in terms of progress in that direction. So I'll be surprised if we don't do massive progress this year as a field.
Okay, I want to close the Gen AI chapter. Let's see then. We should record an episode in a year and see. I mean, AI is progressing super quickly, so you might be in the right path. I'm maybe a bit more pessimistic, but you're right that AI is progressing so fast that we might get some crazy progress very soon. Just one question before we finish the episode. So this show is called AI Stories. It's really focused on career as well. So if you had one advice for people to progress in their career, what would it be? Just one advice.
Work on things that they are motivated and they love. Like that's working on something you love is the best way to enjoy. Uh, and put a lot of efforts on that. When you combine both, you're likely to succeed.
Well, Thomas, thanks a lot. It was great to have you on this show. Have a great day in Paris then, and hope to catch up very soon.
Thank you very much.
Thank
Have a
you.
good day.